Recursion. Recursion is a concept in algorithms where a function calls itself directly or indirectly to solve smaller instances of the same problem. So, what happens here is you have a larger problem, a complex problem, and in order to solve this, you'll break this complex problem into smaller subproblems. And how do you solve these smaller subproblems? You'll use the same function which is supposed to solve the larger problem. So you'll keep calling the same function in order to solve all the smaller problems. That is how you solve in recursion. So you'll solve this using the same function, maybe with a smaller data set, maybe with a smaller range. So you're reducing the complexity of the problem but calling the same function again and again in order to solve all these smaller subproblems. And once the smallest subproblem is solved, the result will be returned to the previous subproblem. So once this gets the result of the previous subproblem, solving this becomes easier. Once this is done, this again returns the result. Again returns the result. So once this is solved, it will return the result to the larger complex problem. So once all the previous subproblems are solved and the partial result is returned, solving this larger problem, this becomes a easier task. So this is how you solve a problem using recursion. I'll give you an example which makes the whole understanding much easier. So just imagine that you are here in exam hall. You are writing the exam. You are in the first bench. And let us say this is a multiple choice question examination and you don't know the answer for the fourth question. You don't know how to answer fourth question. What will you do? You'll just turn back and ask the person sitting right behind you. What will you ask? Do you know what is the answer for the fourth question? So this is the question that you asked him. Maybe he is also not sure of. So he'll also do the same thing. He'll ask the person sitting right behind. Again, he'll be asking the same question, the same function, the same question he'll be asking to the person behind. Do you know the answer for the fourth question? Maybe he also don't know. So he also repeats the same thing. Again, he asks the same question backwards. What is the answer for the fourth question? So maybe this person has some idea, but he's not sure of the answer. But he knows there are four choices, A, B, C and D. And while looking at the choices, he understood that D is not the right answer, but he don't know whether A, B or C is the right. So what will he do? He has that partial information. So he'll return saying, I know it is not D. So he'll return saying not D. But I don't know what is the correct answer, but I know it is not D. So now the third person, he understood that it is not D. So he'll now look into the answer because the task got simpler. He understood that it is not C as well. So he returns to the second person saying, according to what I know till this point, the answer is not C, the answer is not D. It can be either A or B. Now with this information, this person, the one in the second position, he again looks back to the question and he somehow identifies that it is not B as well. So what will he return back? He'll return back saying it is not B, not C and not D. Now your task got much easier because you know there are only four choices A, B, C and D. And according to the information that you got back, it is not B, not C, not D, which means the answer is A. So this is how it is solved using recursion. In order to solve this larger problem of whether it is A, B, C or D, what did you do? You recursively call the same function again and again. You ask the previous person the same question. What is fourth answer for the fourth question? He also asked backwards, same question. And once it reached a person who has some idea, that is the base case, when it is hit, what happened? That person returned by solving it partially. He gave the answer a smaller problem, that it is not D. You have four options. Eliminating one option is a smaller problem. So this guy eliminated one option. Similarly, this guy again eliminated one option. This guy also eliminated one option. At this point, your task is easier. You know what is the answer. So this is how a recursive problem works. You have to make recursive calls of the same function into smaller subproblems, and once those smaller subproblems are solved, it's easier to solve the larger subproblem. This is recursion. So what are the key components of recursion? First component, the key component, is the base case. Base case. What is a base case? This is the condition under which the recursion stops. So when you were asking this backwards, there were many people, and where did it stop? It stopped when there was one person who could directly eliminate one option. So this was the base condition that was hit. So whenever you are writing any recursive solution, you should always have a base condition, that is a condition at which your recursion will stop. Otherwise what happens? This call will keep going on. This will keep going on to the next person, next person, next person, and so on. But if no one knows the answer, what happens? The return won't come back. So you will keep waiting for the fourth answer. You won't proceed to the fifth. You are stuck at fourth, waiting for the answer, but the return didn't come at all. So your time is simply wasted. So in order to avoid this, you should have a base condition under which you are sure that it will be returned. At some point, maybe your base condition is that if it already went to 10 people, then you should come back. You should not again go backwards. You should come back. So something should be there as a base condition which would put a stop to the recursive calls. So this is the base condition. This is one condition. While you are writing recursive problem, you should always have this base condition. Next thing is the recursive case. If you know these two things, you are good to write a recursive problem. One, you should know what is the base condition, where to stop recursion. And secondly, you should know what is the recursive case. What is the call you should make? How should you divide this into a smaller problem and make a call of the same function to resolve that? That is the recursive call. So we'll understand this in deep with an example. So when a recursive function is called, what happens? The current function execution, let us say you are executing some function. While you called recursively, maybe you called f of 2 recursively from f of 1, what happens is the current function execution that gets halted. This stops and waits for the result from the previous, for the recursive call. So as we said in the example, when you were making a recursive call backwards in order to get the answer for the fourth question, you are not proceeding to fifth. You are waiting for the answer. Similarly, whenever a recursive call is made, this function will keep waiting so that the result is returned from the recursive call. And the smaller problems, they will be addressed by calling the same function again and again. So once you hit the base case, when the base case is hit, what happens? The function begins to return. So base cases from where recursive function will start coming back. So what we'll do, we'll understand this with a very simple, very basic example so that you clearly understand how is recursion working. Let us take a very basic example. Let us say you want to add some numbers. You want to add n natural numbers. This is the task, a very simple task. So let us say add numbers. What is this function? Into this function, maybe you will give input n. So you want to add first n natural numbers. So how will you do? You will have sum. Okay, sum is equal to 0 to begin with. Then you will have a for loop. Here I am just writing an iterative solution. We'll convert this to recursive. So I want to show you how to convert an iterative solution to a recursive solution. So first I'll write iterative part. What you'll do, for I is equal to 1 to n, right? From 1 to n, you'll keep iterating. At that time, what will you do? You'll make sum is equal to sum plus I, right? This is what you'll do. And once this for loop is completed, you will return sum. So this will have this sum of first 10 natural numbers. So what will happen if you give n as 5? If you give n as 5, at this point sum will be 0. From 1 to 5, you are iterating through this. What will you do? Your sum is initially 0. At 1, it will be sum equal to 0 plus 1, which will be 1. Then I will be 2. When I is 2, this will be 1 plus 2, which is 3. Then you will do I equal to 3. So you will get 3 plus 3, which is 6. Then I will be equal to 4. Then 6 plus 4 is equal to 10. I equal to 5. Then 10 plus 5 equal to 15. So you got sum of first 5 numbers is 15. So this is the iterative solution for that. This for loop is what works. So for converting to this to recursion, first thing I'll do, instead of I equal to 1 to n, what if I write I equal to n to 1? This also works the same. So instead of iterating from 1 to 5, what I'm doing is I'll first take 5, then 4, 3, 2, 1. This is also the same. So this time also sum will be calculated correctly. Initially sum will be 0 and you will make it when it is n, this I is equal to 5 to begin with. So sum will be 5, then I will be 4. So 5 plus 4 is 9. After that sum will be 3. So 9 plus 3 is 12. Then I equal to 2. So 12 plus 2 is 14. Then I equal to 1. This is the base case. When I equal to 1 is reached, sum is equal to 14 plus 1, 15. So this is how you find sum of all 5 natural numbers. So till now it looks all good. This is the point at which I am going to convert this to recursion. So instead of this code, what am I going to do? I'll tweak this code. I'll tweak this code such that I'll first have a base case. What is my base case? From n to 1, if I want to go, then my base case is whenever I am reaching 1. That is my base case. So my base case will be, if n is equal to 1, what will I do? I'll return 1. This is my base case. So when there is only one number to add, the sum is 1. That is what I'm returning here. That is my base case of recursion. Next thing is, I should know what is the recursive call. So instead of this for loop, I'll have a single recursive call. What will be my recursive call? I'll say return. What should I return? N is the present one. N plus, I'll call the same function, add numbers of n minus 1. This is my complete recursive function. So if you see this and compare with the iterative solution, this is much easier to understand and this is more logical. So how are you calculating sum of n natural numbers? You add n to the sum of n minus 1 natural numbers. So this is the simplest way I can explain. That is, someone is saying you have to add numbers, first 5 numbers, sum of first 5 natural numbers. So I am telling you, in order to find this, how should you find? You add 5 to the sum of first 4 natural numbers. So this is recursion. This is the concept behind recursion. And how do you find the sum of first 4 numbers? In order to this, you add 4 to the sum of first 3 natural numbers. Go on like this till 1. So this is the logic of recursion. I'll show you with the recursion stack as well. This is my recursion stack. So in recursion stack, why is there a stack? Because in recursion what happens is you call a function. Every function when it is called, it will take position in a stack. So when you call another function on top of it, the call that you made, that will be put over this in the stack. So that's how it works in algorithms. So let us try this. I want to take sum of n numbers. So add numbers of 5. So how will I add 5 numbers? Recursively, what I'm doing, I'm checking whether n equal to 1. In case n equal to 1, I have to return 1. N is not equal to 1 here. So what will I do? I'll do n plus add numbers n minus 1. So 5 plus add numbers of 4. So what will this do? This has to add 4. So this will make a recursive call which will do again the same thing. 4 plus add numbers 3. This will again make a recursive call. 3 plus add numbers 2. This will again make a recursive call. 2 plus add numbers 1. What happens at add number of 1? In add number of 1, the value of n is 1, which will return the value 1. So this is the base case. The value. So I want you to understand how the base case is working here. So when it hit the base case, that is add numbers of 1, it will return the value 1. So here this will return 1. So now it is 2 plus 1. So this 2 plus 1 will be returned to add numbers of 2, because add numbers of 2, what is it doing? It is returning 2 plus add numbers of 1. So that is what here you saw. So this will be 2 plus 1, 3 will be returned here. Now 3 plus 3 is 6. the 6 will be returned here. So I'll pop this off. 6 is returned here. Once this 6 plus 4, this will be 10. This will be returned here. So when it is returned, this 10 is here. 10 plus 5 is returned here. So finally you got 15. So this is how, using recursive calls, you did the same work that you did with iterative solution. So whenever you see an iterative solution, you should understand that it is always possible to implement the same iterative solution using recursion. But how complex will it be? That's a different question. Whenever you see an iteration, you can do it with recursion as well. But similarly, whenever you see a recursion, you can convert it to iteration. But the problem is you never know how complex it will be. Sometimes converting a recursion to iteration will turn very complex because recursion is generally very logical. It will make a lot of sense and it will be easier to read and understand. Maybe in the initial stage you may find recursion difficult, but once you get used to recursion, you will understand that it is logical. It's easier to grasp because just see this. If you want to find sum of 5 numbers, it is saying add 5 to the sum of 4 numbers, which is very logical. So this is easier to understand and you solve the question with a single line actually. You have a base case and a recursive case and you solve the whole problem. So this is the beauty of recursion, and you always need to keep in mind that it will take some space. Always recursion will take some space. That space is used because of the recursive stack. So your space complexity will keep increasing whenever you use recursion. And sometimes when you substitute recursion with iteration, you will be able to save the space that you're using for recursive stack. But always this is the trade-off. Recursive solution will be logical. It will look easier to understand. Many times recursion will be easier to implement or easy to write. So as we go forward, you will get used to recursion and then you will see the beauty of recursion. It's much easier to understand, easier to read, and you'll really appreciate the concept of recursion. I know when you're beginning, it will be difficult to grasp, but once you get used to recursion, it's much easier.